All right, let's talk about a new AI model from NVIDIA that's making some serious waves. It's called Nemotron Nano 2, and the whole idea is packing an incredible amount of power into a surprisingly small package. So let's dig in and see how NVIDIA is trying to rewrite the rules of AI performance. So what's the headline here? The big number? Right out of the gate, NVIDIA is claiming this model can achieve up to 6 times the performance on complex reasoning tasks compared to other models of a similar size. I mean, that is a huge leap in efficiency. It means getting answers and finishing jobs in a fraction of the time. And that's the million-dollar question, isn't it? Usually, to get that kind of speed, you have to sacrifice some smarts. But NVIDIA says they've cracked the code on this one. So how? How did they manage to build an AI that's both ridiculously fast and just as smart as its bigger, slower competition? To really get why this is such a game changer, we got to talk about a fundamental problem that's been bugging AI development for years. See, for a long time, there's been this constant, really frustrating trade-off. It's always been a choice between two extremes. On one hand, you've got these absolute behemoths, these giant, super intelligent AI models. They're geniuses, sure, but man, are they slow, expensive to run, and they just guzzle power. Then, on the other hand, you have the smaller models. They're quick, they're cheap, but they're just not as smart. You always had to pick one, raw power or practical efficiency. This is where Nemotron Nano 2 comes in. It's trying to give us the best of both worlds, and it all comes down to its secret sauce, a recipe built around 3 core innovations designed to finally break that old trade-off. So you've got a world-class dataset to start, then this really clever hybrid architecture, and it all gets wrapped up with a process that's basically an AI shrink ray. Let's take a look at each one. First things first, you gotta have good data. You just can't build a great model without it. Nemotron was pre-trained on a massive dataset of over 9 times trillion tokens. Think of tokens as little pieces of words. And what's really key here is the mix. It wasn't just random text. It was like a perfectly balanced diet of high-quality stuff from the web, academic papers, text in multiple languages, complex math, and computer code. This builds an incredibly solid and versatile foundation. Next up is the model's architecture. Its guts, basically. And this isn't your standard issue model. It's a hybrid, kind of mashing together the best parts of 2 different powerful designs. You take the transformer, which is the gold standard for reasoning in AI, and you blend it with this newer, super fast design called Mamba. By mixing them, the model can chew through long stretches of information way more efficiently, but without losing its intelligence. Okay, and this final step is probably the coolest part. They take this big, fully trained model and they run it through a 2-stage compression process. First, they prune it. Think of a gardener carefully snipping away the branches that aren't really helping. Then comes distillation. This is where you basically transfer all the wisdom from that larger model into the new, smaller structure. It's like taking a whole library of encyclopedias and boiling it down into one perfect, brilliant study guide. It's way smaller and faster, but it still has all the critical knowledge. Okay, so the theory sounds fantastic, but does it actually work in practice? Let's dive into the numbers from NVIDIA's own paper and see how this thing actually stacks up. Yeah, this chart pretty much says it all, doesn't it? Look over on the left at measured accuracy. See that green bar for Nemotron? It's right up there with its competitor, neck and neck. But then look at the right, measured throughput, that's speed. That green bar just towers over the other one, more than 6 times taller. The takeaway is just crystal clear. You're getting the same level of intelligence, but at a ridiculously higher speed. And if we zoom in on a few specific tests, the advantage gets even sharper. On MMLU Pro, which is a big test of general knowledge, it scores higher. Cool. But look at the math benchmark. It's not even a competition. Nemotron hits a massive 80.5 compared to 55.4. That is a huge lead. And on Ruler, which is all about handling super long documents, it sets a brand new high score, while its competitor doesn't even have a comparable result listed. So look, this is more than just a cool research paper. An AI model that's this powerful and this efficient, well, that has some massive real-world implications for basically everyone. Let's talk about why this is such a big deal. And maybe the single most important thing to understand is this. Because it's so crazy efficient, Nemotron Nano 2 doesn't need some giant, super expensive data center to run. It's built to operate on a single, widely available NVIDIA A10G GPU with just 22 gigabytes of memory. That puts this insane level of AI power into the hands of, well, millions of developers, researchers, and creators. So what's the big picture here? Well, by making these models open source, NVIDIA is basically democratizing access to this kind of cutting-edge AI. It means you can run powerful AI on hardware you can actually get your hands on, which is going to spark a whole new wave of applications. And, this is really important. Making AI more efficient also makes it more sustainable, which helps reduce the massive energy footprint of this amazing technology.
And that really is the question, isn't it? We've just seen how NVIDIA basically broke that old trade-off between size and power. The result is an AI that's not just smart, but it's small, it's fast, and it's accessible. So, when a tool this powerful gets put into the hands of way more people, what are we going to create next? I mean, the possibilities are just starting to open up.